What's going on, everybody? Welcome back to the stream. Hopefully I'm coming in loud and clear. This is Phoenix with another video today. This is going to be a little bit of a different one in a sense that we're doing trying to do developing on EOS as a noob. So I thought I'd just share my experience. What you guys should see on the screen is my screen share with EOS Studio being shown. And what I'm hoping to actually get out of this is improve communication skills, improve technical communication skills. As I had mentioned in my previous video, I am working through a basically a boot camp, a series, and part of the exercises we are basically working through is our technical communication, because that's a huge integral part of working on a team to basically develop an application, and also just to sell yourself on your competency, right? And so part of it is if you're able to explain something to other people, I think it shows a mastery of the material. So over the past 6 or so weeks, I've been learning and acquiring knowledge on JavaScript, starting the React series, and I've also started through the EOSIO certification program. So I figured what we do today is go over the tic-tac-toe series that I'm working through, and I'll just share with you guys my own struggles, my pitfalls. I'll also put later in the chat, not with the live stream, but probably later in the chat during the replay gang, I'll put a link to, I've been showing this Calendary link I'm been distributing. And so the idea is that as a community, maybe we pick a time, like a time slot, a day, and say an hour or 2 hours, where people who are interested in becoming a developer basically just sign up for a time slot. And the way it works is we do what's called pair programming, which means that we first sort of assess people's skill sets, where they are at in the journey. You know, are they at the very beginning stage, knowing nothing about blockchains and JavaScript and React, maybe to progressing towards much more experienced folks. And so we kind of developed the skill system that through several weeks of being consistent, we're able to basically build a pipeline of developers that can build some cool stuff, right, on EOS or EOSIO. It doesn't have to be EOS. I think the skills translate to many other things, but my particular goal is more of a hybridized application solutions. So unlike a lot of people in the community, I actually see that think the apps will be hybridized in nature. They'll have some central components to them and perhaps some decentralized components to them, right? Especially if we're, thinking about reinvented business models. Most of those reinvented business models as an incremental step may be centralized, right? So part of my goal is to understand that value-added benefit to average everyday users, right, who don't know the narrative of decentralization. So I think that's much more broad appeal versus trying to, say, go from 0 to 100 and go fully decentralized when we don't have a truly functioning, arbitration system, and also the regulations just aren't there. So that's going to be my goal over the next year, guys. But I thought I'd take you guys in the journey. I will be setting up a separate technical channel, so it'll be probably called EOS Deving, or I'll come up with something on YouTube just so that I can keep the content for the developers separate from, and my journey in developing versus the traditional content I create. So what you are seeing on the screen, like I mentioned, is just this is the instance of my local testnet, and we use these for basically simulating interaction with the EOS blockchain. In this case, I'm looking to actually build on EOS at some point, or hash to it. So I figured I'd try to get some familiarity with how this works. And so I just spun up a couple of these test nets. One of them's running right now. And before I get into that, I didn't finish the paired programming concept. So let me finish that fully. So how paired programming works is, so we pair 2 or more people together, and basically we designate a driver, what's called a driver, someone who actually implements the code on screen. And we have what's called a navigator. And so a navigator is someone who essentially will articulate in words or help the driver code right through the exercise. And so in the series of maybe an hour, maybe we try to tackle, one particular challenge, more simplified challenge, and maybe progress from there into multi-day challenges, right? Where each day we kind of take a little bit of a chip. We chip away at the problem and we work through any issues. It's something that the bootcamp I'm actually looking to attend in June uses, and I found it actually very useful in not only understanding the nuances of the technology, but also being able to express and share the knowledge with others, right? And developing the pseudocode as we go along. So a big part of I think what I've learned in developing so far, 6 weeks in, I'm not a developer, is the value in communication and the value in pseudocode actually, and the value to research documentation and see what examples there are out there. So again, what we're going to be going over today is more a basic project I've been working through, which is the tic-tac-toe series that is I think B1 has it in their certification program. So we're going to take a look at that today. And it starts with this directory in EOS Studio. So I created a directory, in this case, tic-tac-toe. It has an include directory, a subdirectory under that project folder. And then I have a source folder, and I have my CPP implementation file. So what this allows us to do is basically write the code, right? So I'll take you through a couple of these lines, and then I'll probably call it a day. I'll do the demo, and I'll call it a day for now, and I'll kind of discuss maybe in the next video how I'm progressing as a noob, and you guys can laugh or see how I kind of evolve as we go along. So lines 1 and 3 are our include statements, and these allow us to essentially gain access to methods, right, that we would not otherwise have access to. They are an integral part of developing basically solutions on EOS IO or other types of systems you'll be basically developing, because often, we're not creating something absolutely from scratch. So everything's kind of a derivative of previous works, and developing smart contracts on EOS IO is really no different. So we can see that in this case, the first line includes some of the core code from EOS IO. We use including contracts, which I'm going to use in this example. I also included a vector library, and that's used for some of the types for this project. Line 5 here is using the namespace EOS IO, and what that does is it provides the scope for various methods or objects within my code set, because if I did not provide that, in many cases I'd have to put in EOS IO and then a double colon. And I can discuss that a little bit more if folks want to talk about that. Just kind of have like a coffee session or something we do every day where we learn a little bit every day. Line 8 is my start of a contract itself, a class, in this case tic-tac-toe. That is something you name for your contract. So in this case, it would normally be your contract name there. And normally your contracts are going to inherit, which is this single colon mark, inherit the the Eosio contract, right? Because there's certain methods or objects or functions that are built within the Eosio contracts code that we want access to as part of developing our contract, our specific contract, in this case, tic-tac-toe. So then from there, I use the keyword using, and I kind of use I believe it's like a class constructor to construct the underlying contract. And then I start to, that's line 9. Line 11 is building my table, which again, I'll get more into maybe in a later video. But I basically have so far created 2 tables. One is, or structures, I should say. These are actually tables, but it's more of a C++ struct format where I'm labeling the different elements within the table. So I'm kind of defining the format, the data types of the data I'm actually going to store in these tables, if you call it that. So I'll have a key, and that key allows me to kind of point to where in the space, a record is, right? And I have a host name and an opponent name, and that tells me who's basically playing the game. It's kind of a silly example, but it actually is very helpful in just understanding the nuances of what all's involved in developing a blockchain application, because this particular example forces us to create, read, modify, and delete the CRUD, basically, for this platform, right? And then I have a winner, and the winner is designated to tell or keep track of maybe who the winner is for a particular game. I also keep track of whose turn it is through the use of an integer. That's line 26. So I declare a uint 8. I think that's a 8-bit series integer called turn, and I have a default value there of 1. So these equal signs that follow the name of these data sets within my games table are basically default values. So I wanted to default the winner to 0, meaning no winner had been chosen. And you can see here in my code set, which I will ultimately upload to GitHub, I've basically created more pseudocode than I think B1 or most of these examples have, because I find that to be helpful as I go through my code development process, just to think through it and make sure I'm able to articulate that to you. I kind of make a label here of what things mean and how I'm going about solving these problems. I then created some primary key associated with the key record in my struct, which was the first item here in my struct table. And then I created some secondary indexes, and that allows us to basically create search algorithms or search solutions for these tables. So it allows us to, like, say I want to search not only by key, but maybe by the opponent name or by the host name. Setting up those secondary indices allow me to do that. And then I have a serialize, which tells I believe the compiler, or tells the code, certain order set and the different data that I have that make up this struct. I don't think that's absolutely necessary, but it is recommended. I did a similar thing for the board table, which I'll discuss in a later video. I did default the board's vector. Vector is just a series of it's like a dynamic data set. In this case, it's sort of a set of integers that are like common to one another associated with the term boards. And I've defaulted all the positions to 0. You'll notice if you count up the digits there, I have 9 because this is tic-tac-toe. So the idea here is that I'm using these vectors to represent essentially positions on the board. And the value within each of those positions is intended to reflect if the position's empty, if it is occupied by the host, or occupied by the opponent. And so using just 3 digits for each of those slots, I can basically represent the state of the tic-tac-toe game, right? So we haven't really gotten into, I guess one thing, obviously, with today's demo I'll show you guys is I haven't really gotten into the visualization of creating this application, this simple application. So that'll be next. I may even jump ahead a little bit and start a little bit of that process next week and then jump back into some more bench testing optimization of this code. Again, it is a dumb example, but I think there's a lot of things I've learned just from trying at least this and showing up. And then I've created some type def, Eosio, multi-index tables. So this takes the struct and it converts it or translates it into an actual multi-index type of Eosio. And we're also able to give the tables their names. So in this case, I have a games index and I have a boards index. And we'll link those to later actions. Actions are just methods we have with the blockchain, right? So if you have like a explorer and you want to interact with that with your account, actions allow you to basically do that, right? Through parameters in these action statements. So I have a create action that takes as parameters host and opponents, and we pair those with arguments within our interactive space, right, of our contract. So I'll show you guys an example of that here real fast, but just keep in mind these actions are basically things that you can interact with as users, and you can actually interact with them even through explorers, like I mentioned. It's pretty interesting, and that is actually covered in the certification program. So for those that are interested, I'd actually recommend you guys check that out. In most of these codes, you'll see that there's a check has auth requirement at the start of an action, and that's basically there to prevent unauthorized accounts from taking actions on other users. So in this case, we want to make sure that in this particular example, we're checking that the host is authorized. So if they do not have the authorization, but they're acting on behalf of that account holder, we would return an unauthorized error code, and I'll show you guys that. We also check, for example, that the host is not the same as the opponent. These are simple checks, but you can see there, we'll throw an error, and then we start to get into instantiating, I believe is probably the term. The game, we call it the game object, or it's like the table, the reference to the table. So we take games index, which was our table name. We create the game, which is a reference to that actual table stored within the scope of our contract and the contract's account, right? So the get self basically references this tic-tac-toe contract and account. In some other cases, we could store it elsewhere, and I think part of the whole reason why Eosio had that feature in the beginning was at some point there was a plan to use this as like for an IBC solution, but I don't think that really took off. Then we jump into creating some index or leveraging some indexes, and taking those indexes we created in our multi-index code. So in this case, I'm referencing my opponent ID index that I created above. It's a secondary index, and why I created that was so that I could find where within my table set the opponent name was, and if it does not exist, I will return an error. And then I take that same data set and I check to see, well, actually, let me back up. What I'm doing here on line 112 is I'm checking to see if the opponent name already exists in my table. So part of my assumptions in developing this game is that there's only one game that's allowed per account. Like you can only have, as a user, one of these going on. Can't have concurrent games because it just causes other issues with the particular simplified code. So we kept it, if you have a game ongoing, you're not allowed to go into another game with that single account. And then we also wanted to check to make sure that, similarly, we wanted to look at the host and make sure that the host wasn't in the records table. So there's actually 4 checks you do if you think about the permutations, because you have the host field, and it could have an opponent name or a host name. And then you have the opponent field, which could have the opponent name or the host name. So you end up with 4 checks there at a minimum, in addition to the other checks we mentioned. And so most of these lines of code you see here are just those checks. Once you confirm that you basically do not have the record established with these users and it is unique and they are authorized, then we can start to actually create the records. And we use the in-place method for that, which is a C++ method. It takes as a argument the payer. In this case, we're going to use the contract to pay the resources to actually initiate this account. And then the second parameter on line 132 is called a Lambda function. And a Lambda function is basically like it's basically a method that encapsulates this entire function within the parameter. So you guys may or may not be familiar with that, but we can walk through it. It's not too bad once you actually get used to it. And then we create this new underscore row, which is passed in as reference. We populate those with the data sets from what we called into our functional argument or action. In this case, it's create. So we take the information, in theory, it would actually be from a GUI, right, or from an app. But in this case, we're going to feed it in, and then we're going to create those records within our blockchain table data set. We do a similar thing to create the boards record in that table. So we have, again, a game table, which keeps track of active opponent, and a host, and who's winning, and that kind of stuff. And then we have a separate table that keeps track of the state of the board, right? And then we have some indices there that help us to basically identify where in the stack those users are associated with a particular board game, right? So what we did in this case is I linked the user ID to a board ID, and so there's kind of like a I don't know if you want to call it like a primary key, or primary key, secondary key relationship for those that are familiar with like databases. But I did a similar thing here. It probably wasn't needed because, in a sense, I guess in theory they could, since they're coming sequentially after one another, maybe they could use the same ID. I didn't think that was a great practice, so we actually did them, and we had them each generate their own unique primary keys, and then we referenced the game table primary key to the board primary key, and then we just do lookups. I am kind of curious to see from an efficiency standpoint, what some other developers do to keep their codes more efficient. I think in this case, one of the things I learned is I will need to look through my code to address or not DRY, or don't repeat yourself, basically, right? So I have a lot of that don't repeat yourselves with I think like some searches with tables and those types of things I could probably do through a generalized function. So those are things I'll probably look to implement in my code. But so far so good. So I'll give you guys a quick demo of what I have so far. So I've already built the code through this build, and I've already deployed my code to my contract account. In this case, I'm using the tic-tac-toe account. And so if you go over to the tab here and we go into, you can see these are some of the accounts I created just for an example. And I've actually already created some data for games that I've simulated are ongoing. So you can see here I have 2 games. Key 0 is JP and Mary, and there's no winner so far because winner is 0. And the turn is 1, meaning it's the host JP's turn. And then the second game is a host by the name of 2 and an opponent name by the name of 3. There's no winner there, and the turn is with host. So it just kind of gives you an example of how this works. Associated with that, like I mentioned, is our board table. So naturally we have 2 of those. And you can see one of these is has a key of 0 and a game ID of 0, and the board bytes are shown. And then I have another board to represent that other game I talked about, because there were 2 games, remember. So if we wanted to, you could see here there's actually some data. So 0s represent empty board sets, but you can see in the case of, I think this might be JP's, there's data in here. And if you guys recall, the 1 meant it was the host occupying a position, the 2 means it's the opponent, and 0 means it's empty. So what I'm going to do is I'm going to, just for the purposes of today, demonstrate my reset function, my reset action, or my restart action. So I'm going to go here to my function tab on the left, I'll go to restart, and we're going to type in the information that is necessary. And actually we'll do a couple checks here just to demonstrate to you guys kind of the logic that we've put into this to make sure that it actually has some dumb checks, if you will, to avoid silly errors. So in this case, I put Mary, by the way, for my account. By means the person initiating it. Up here, I have Eosio, so there's a mismatch there in terms of the account I actually have access to and what the app is receiving. So this should actually show an error because we don't have the right assertion from the account holder. So I'm going to run the code, and you can see there the result. I get an assertion failure with the message unauthorized account authorization. So that is what we expect because, again, there's a mismatch here. But if I were to go to, say, if I were to match these, so Mary's here, JP and Mary are playing. This is by Mary. So if I change the account here to Mary, now you get a match. So if I and my table IDs here, so if I hit the execute button now, I should actually see all these basically reset to 0, right? So let's try that. And there you go. Execution succeeded. I get a transaction ID. We can actually open this up if we want. Take a look at the ID. Take a look at the data in raw form, more of a JSON format. And then to validate that my code is actually working correctly, we're going to hit the refresh button. So you can see here we've zeroed out that data set. So now it's a complete empty board, right? So it's functioning correctly. So now we can play with some other functions that I've created. I can do a move. We can do, again, JP and Mary, and this time JP is going to move, and let's say I want to move the first position. So the positions that I show here are from 0 to 8, and the reason behind that is because arrays actually start their positions at 0, not 1. And tic-tac-toe has 9 positions, so 0 to 8 make 9. So in this case, I'm telling the computer that, or telling the code set, I want to actually occupy as JP the second position, right? I want to put an X there, some symbol, to be determined when I make the GUI. But basically, this logic should work. So we're going to try this out. And actually, in this case, I should get an assertion failure because, again, I'm logged in as Mary in my account, but my by is JP. So I'll show you guys that again just for good measure. There you go. Get a invalid account or unauthorized account. So now if we change this to JP, should run just fine. There you go. Execution succeeded. And what I've done in my set here, in my data set, is I've console.log. So console.log is a really effective way to troubleshoot your code. And in the raw syntax for Eosio, there's a way to track these things. So what I've done is I've actually logged into the console my basically that vector set. So if you count the numbers here, there should be 9 numbers where it says console. There's 9 digits. And so, you know, again, I start at 0 and I go to 8. So you can see the second position now shows 1. So that makes sense. That's what we wanted. Now, what if we change this to be, let's change it to be Mary. So we're going to go to the opponent. So that number should be 2. That is at that position. So let's say that Mary wants position 3 to show her symbol. Now what we would do is go here. Now we get an assertion failure because I'm logged in as JP. So change that to Mary. And there you go, your execution succeeded. So if we go to that raw data, you can see here on the console, oh, right here. You can see here that we updated that as well. So now that fourth position shows 2, which is what we wanted, because again, the integer here is 3, but you have to remember that the vector starts at 0. So when you say 3, it's actually the fourth position. So it actually works out. So what are my next steps for this? I got to do some more optimization of the code. I got to do some more checks, some simple checks, but I have at least the create, the reading, the editing, the modification of the record sets. I have the most of the is valid move done. I need to implement the winner function, which is going to go through the code and come up with patterns that represent a win for a particular user. So hopefully by next week I have those updates. I am trying to do this kind of not looking so much at solutions. What I do is I like to code this out in a pseudo way and research on EOSIO developers, or go to the developer chat room and do some research there to understand how this works. One thing I have kind of struggled with thus far is the find method with secondary indices. I've noticed in some cases when I provide the reference to the record, like that actual iteration using a secondary indices, and I use a check function, it doesn't seem to work. So I'm having to then take that reference and do another find with the primary keys. That seems to be what I've been able to work around thus far. I'm also curious to know if there's significant memory that's associated with storing those secondary indices. So those things are to be, I guess, explored further. But yeah, if you have an interest in this, certainly after this live stream goes, I will update the video to show probably the new channel. Probably do that tomorrow. And I'll also provide a link tonight with the Calendary link. If you guys are available or interested in doing these pair programming sessions, probably would be like an hour, maybe an hour and a half. We go through simple things like Hello World, or we do JavaScript exercises, because a lot of it is not just C++, but we also need to build up our front end skills. And so the only way to do that is to actually show up. So want to get your thoughts on this video. Hope you guys enjoyed it. Know it's a little bit different, but I thought I'd show you guys some other things I'm doing as just someone who's here learning. And yeah, appreciate your time always. If you like the content, consider hitting the like button. Consider subscribing to this channel. So with that said, this is Phoenix signing off. Peace.